Hello, today we're going to talk about section 1.1, graphs of equations. We're going to look at sketching graphs of equations. We're going to identify x and y intercepts, using symmetry to sketch graphs of equations, write equations and sketch graphs of circles, and use graphs of equations in solving real-life problems. So we've used the coordinate system to graphically represent the relationship between quantities. There, the graphical picture consists of a collection of points and coordinate plane. This relationship is expressed as an equation in two variables. For instance, y equals 7 minus 3x. That's an equation in terms of y and x. If we had an ordered pair, we write those in parentheses, a comma b, where a is a solution or a solution point of the equation in x and y. If you take the a value and plug that into x, the output value y will be your b. If that's a true statement, then it is a solution to that equation. So the coordinate point 1, 4, that is a solution to y equals 7 minus 3x, because if we change the y to 4, and if we changed the x to 1, as indicated in the given point, we get a true statement, because 4 does in fact equal 7 minus 3. That's not the only point that's true for that equation. That's just one solution to that equation. If we were to plot every possible point that would solve that equation, we would end up with a graph of a line, and that's going to be the graph of the equation. Not always lines, but for this case it would be a line. The basic technique we're going to use in sketching is called point plotting. So when we do a point plotting, we will actually make what's called a t-table. We'll have a table of values, determine values that we want to plug in for x to get a corresponding y that goes with it. So to do that, you want to get one of the variables by itself. Normally when we do that, we're going to solve for y. That's just the custom. That's what we're used to. But you don't always have to solve for just y. After your table of values has been made, you can plot those points on your rectangular coordinate system, and then draw your line or curve depending on what the graph might be. When choosing values to plug in, it's really important to choose negative numbers, 0, as well as positive numbers. It's very, very common and easy to plug in positive numbers, but forgetting that negative numbers and 0, we don't see what's happening there. And a lot of times, weird things might happen in those areas. So make sure you choose all possible values when filling in your table. So an example, if we're going to actually sketch the graph of y equals negative 3x plus 7. First of all, we want to make sure one of the variables is isolated, and fortunately, they actually given us this equation, and y is already by itself. So if we're going to make a table, for instance, as I show in the example here, if x is negative 1. When x is negative 1, you plug it in, so you get negative 3 times negative 1, which is positive 3. 3 plus 7 is 10. So when you plug in negative 1, your input, your output is 10, which gives you the coordinate negative 1, 10. This tells us that the point negative 1, 10 is on the graph of y equals negative 3x plus 7. I'm going to go ahead and go to the next screen here, and we're going to see a table already made for us. And if you'll notice, what's happened here is they have chosen some values for x. We have a negative 1, 0, 1, 2, 3, and 4. In the second column, this is the actual function itself, y equals negative 3x plus 7. Well, we just saw that when you plugged the negative 1 in, the output value was 10, so that coincides with the point negative 1, 10. Similarly, if we plug in additional numbers, say 0, when you plug in 0, negative 3 times 0 is 0, 0 plus 7 is 7, so of course the output is 7, so the point 0, 7 is also on the line. And we can do that for different values of x. And you can choose these values. For this particular function, x can be any real number, so it doesn't matter what you plug in. Once you're done, we have a system, a set of points that are all on the line of this graph. Moving on to the next screen, we can see that by plotting these points do in fact draw a straight line. We draw a line through them, connect them, and I always like to actually have arrows at the end of my line, because that indicates that line does in fact go on forever. as opposed to ending, as you can see in the picture that they presented us here. It's easy to determine the solution points that have 0, and these are called the zeros. You have an x-intercepts and y-intercepts. So to find the x-intercepts, that is, where does the graph cross the x-axis, you assign a y value of 0, just as to find the y-intercepts, you find values such that x equals 0. So they're called intercepts because those are the points at which the graph intersects or touches the x or the y-axis. And folks, it is possible that you do not have some of the intercepts. Here are a few graphs. Notice in the first graph, we have this curve here, and this curve actually touches the y-axis at that point right there. So this graph does have one y-intercept, but notice as the graph is coming down and then it goes back up again, it never got low enough to touch the x-axis. Therefore, this graph does not have any x-intercepts. On the second graph, we have a little curve going on. It's coming up, and then it goes down, goes back up again, whatever. But that graph touches either the x or the y a total of 3 times. It has 3 x-intercepts, 1, 2, 3, so it crosses the x-axis 1 time. And it also has 1 y-intercept, which is right here. I'll circle that one. So that happens to be the origin. So the origin is actually an x-intercept and a y-intercept because that point does in fact lie on both the x and the y-axis. Our third graph, it has 1 x-intercept, meaning it only crosses the x-axis 1 time, and then 2 y-intercepts. It crosses the y-axis twice. And then, of course, in our last graph, we have a circle over there in quadrant 2. And the circle is totally in quadrant 2, and you'll notice that it doesn't get low enough to touch the x-axis. It doesn't go far enough to the right to touch the y-axis. So this graph actually has no intercepts whatsoever. Some texts denote the x-intercept as the x-coordinate of the point A0. So again, I want to point out that at the x-intercept, that y value right there is 0. So again, to find the x-intercept, y is 0. Flip that around to find the y-intercept, you'll see that the x value is in fact a 0. So unless we really have to say, okay, we're specifically talking about the x-intercept or we're specifically talking about the y-intercept, if I just want to know, hey, what are the intercepts? I'm actually asking for all of them. So that could be either one of them. So here's a graph. This is the graph of y equals x cubed plus 1. And as we look at that, the directions for this problem says identify the x-intercept and the y-intercept of this graph. So as we look at it, the x-intercept, that happens when the graph crosses or touches the x-axis. So the x-axis is the vertical axis here. And the graph does, in fact, touch the x-axis right there. So we have an x-intercept at the point -1, 0. The y-axis, the vertical axis, the graph crosses it right here. So that point right there is the y-intercept. And that y-intercept occurs at the point 0, 1. So again, for the y-intercept, the x value is 0. And for the x-intercept, the y value is 0. In graphs, we have something called symmetry. And symmetry is you draw an imaginary line through something, and if you fold it in half. So if I drew a straight line on this graph across the x-axis, you can see that this graph, if I folded it along that x-axis, it would lay on top of itself. So this particular graph is symmetric about the x-axis. We can go symmetric across the y-axis. We can actually go symmetric about any line. But normally when we're talking about symmetry, we're talking about x-axis symmetry y-axis symmetry as well as symmetry about the origin. So this first picture on the left side here, that is a picture of what y-axis symmetry. If I was to fold this graph right on this y-axis, they would lay on top of itself. Also notice on the y-axis symmetry, if I have some point xy on the graph, then the point negative xy would also be on the graph, and that's where that symmetry comes in. And the last bit of symmetry is called origin symmetry. Origin symmetry, if I have any point, call it xy on the graph, if I changed both of those to negative, so instead of xy I changed it to x negative y, that point is also on the graph. And if I was to draw a straight line right through those points, you would see that that graph through those points does in fact go directly through the origin. So by going directly through the origin, that's what we're meaning, that this particular graph has origin symmetry. And folks, this would be the exact same for any point on the graph. If I was to draw a line from this point on the graph straight through the origin, boom, right there, so those 2 points would also be symmetric. So origin symmetry is actually symmetric through a point, whereas y-axis and x-axis symmetry is symmetric about a line. So again, the 3 basic types of symmetry are symmetric with the x-axis, symmetric about the y-axis, and symmetric about the origin. And again, if it's symmetric about the x-axis, you'll notice that the x values stay the same and the y values change signs. For y-axis symmetry, the y values stay the same and the x values change signs. And if it's symmetric about the origin, both the x and the y values do in fact change signs. So we can conclude that the graph of y equals x squared minus 2 is symmetric with respect to the y-axis because the point negative xy is also on the graph of y equals x squared minus 2. So let's look at this table here. If I chose the value of x, 2, if I plugged negative 2 into this function, I would have y equals negative 2 squared minus 2. And of course, negative 2 squared would be 4, and 4 minus 2 is 2, and that's why I get the point negative 2, 2. If I plug in the value of 2, let me change colors on that one. If I plugged in an x value of 2, so if I had y equals 2 squared minus 2, well, 2 squared is also 4. And 4 minus 2 is 2. So I get the exact same y values on these 2 points. So negative 2, 2 and positive 2, 2 are the exact same distance from the y-axis. So there's your symmetry. And you can see the same is true for the points negative 3, 7, 3, 7, as well as negative 1, 1 and positive 1, 1. So how do you go about testing for symmetry? I want to know, I've got a given function. Is this function y-axis symmetric? Is it x-axis symmetric? Or is it symmetric about the origin? Well, to find that out, all you would have to do is replace y with negative y to see if you get the same answer. So if I wanted to see if it was respect to the x-axis, if I change the y values from y to negative y, do I get a true statement on both equations? If so, then it is symmetric about the x-axis. To see if it's symmetric about the y-axis, what I do is I change x with negative x. And again, if I change x to negative x and simplify, if I get the same equation, yes, then it's symmetric about the y-axis. And of course, if I want to check for symmetry with the origin, I'm going to not only change the x to negative x, I'm also going to change y to negative y. And it's very important for origin symmetry that you do in fact change both x and y to see if you have the symmetry present. Okay, let's talk about circles. Circles might be something new to a lot of you. I know in the high school course that I'm teaching here with college algebra, it was a new concept for them as well as far as how to graph these. And a lot of that is because, well, obviously circles aren't functions. They fail the vertical line test. The equation for a circle is found by using the distance formula. And if you'll notice, the distance formula, which I'm sure you've seen in the past, is equal to the square root of the x values squared plus the difference of the y values squared. And that's the distance formula. Well, if you think about a circle, the circle is a set of all points that are the exact same distance from the center. So this radius is the distance from the center of the circle to any point on the given circle. So that said, I can change that to radius is equal to x minus h squared plus y minus k squared. And I do want to point out this right here. The center of a circle is located at a specific point, and that point is hk. xy can represent any other point on the circle. And folks, it doesn't matter which one. You choose any point on the circle, and it's going to satisfy this equation. So if we were to take this equation, x minus h squared plus y minus k squared, and square both sides, we would actually be able to put it in standard form. So right now, this is not standard form, but as soon as I square both sides, it will put this in standard form. So the standard form of a circle is given as x minus h squared plus y minus k squared is equal to r squared. Again, hk is the center of the circle, and r is the radius. Now, what if I had a circle that was centered at the origin? Well, if the center is the origin, that means that h and k are both 0. Therefore, a circle with a center at the origin would simply be x squared plus y squared equals r squared. So how do I go about writing the equation of a circle? So here's a circle. It has a center at -1, 2, and they gave me a point on that circle that happens to be at 3, 4. And the question says, write the standard form of the equation of this circle. Well, what we would do here is we would start off by writing the general form there of the circle, which is x minus h squared plus y minus k squared equals r squared. And if you'll notice in the point, the center is at the point -1, 2, so I know that h is -1, k is 2, and then they gave me some random point that happens to be on the circle. So x is 3 and y is 4. And by looking at my equation, I realized, hey, I've got everything except r. So if I plug all those numbers in, I will know what r is. So let's plug it in. X, that's 3, minus h. H is -1. Folks, be very, very careful there. H is -1. The equation says x minus h. So that's why I have 3 minus -1. All right, plus y is 4 minus k, which is 2, squared equals r squared. Well, over on the left side, I have 3 minus a -1. That's 4. 4 squared is 16. Plus 4 minus 2 is 2. 2 squared is 4. Equals r squared. 16 plus 4 is 20. Equals r squared. Now, if I wanted to know the length of the radius, I would have to take the square root of both sides. But all I'm doing right now is writing the standard form of the equation of this circle. So remember, in the equation, r squared is a part of the general form. So 20 is going to be part of my equation. I'll now write the equation of this circle in standard form. The equation of the circle is x minus h. That would be minus -1. So plus 1. So again, this whole piece right here is minus -1. That goes right there, okay? So when you subtract a negative, it becomes plus. Squared plus y minus k, which is 2, squared, equals r squared, which is 20. And that is standard form for the circle given in the graph. I'm going to go on to the next slide, and you're going to see that the text has worked it out as well, but you've also seen me work it out step by step. So here's where they did. They went through and they plugged in numbers just like I did. They left the square root the whole time, and they got the radius to be the square root of 20. I do want to point out when I worked it, let me go back and scroll down. Okay. So when I worked it, I left r squared there the whole time because I knew when I got done I wanted 20. This particular problem didn't ask me for the radius. It wanted the circle in standard form, which includes r squared, which is 20. So there, my problem, I worked it out in terms of r squared. That's why you don't see any square roots when I worked it. Back to them working it. They took the square root of both sides, went through, found out that the radius was the square root of 20. And now that we know that the radius is the square root of 20, we can plug everything into our equation. So they plugged in x minus negative 1 squared plus y minus 2 squared equals the square root of 20 squared. By simplifying x minus negative 1, they got x plus 1. Here's their y minus 2. Both of those are squared. And of course, the square root of 20 squared is in fact just 20. Write the standard form of the equation of the circle with center negative 4, 3, and radius the square root of 19. Okay, so again, standard form of a circle takes the form x minus h squared plus y minus k squared equals r squared. Now what did they give me? They gave me the center negative 4, 3, so I know that h is negative 4 and k is 3. And they gave me the radius. They told me that r is the square root of 19. I'm going to now take those values and plug them in. So x minus h is negative 4 squared plus y minus k, which is 3, squared equals r, which is the square root of 19, squared. Cleaning this up, minus and negative becomes plus, so that gives me x plus 4 squared plus y minus 3 squared equals 19, because the square root of 19 squared is 19. All right, and folks, that is actually the end of the section. It was a pretty quick one. Lots of questions about circles, though, so take your time on those, pay attention to those. I should have actually stopped before working that practice problem, but go ahead and stop the video now if you'd like. Come back in a little bit. I'm going to go ahead and work another practice problem on the circle, and you can watch it at that time. Okay. You either stopped and went and worked this problem on your own, or you just kept on watching. So I'm going to go ahead and work this last problem. It says to write the standard form of an equation of a circle with endpoints of a diameter at 4, 3, and negative 8, negative 7. So what's happened here, if I had a coordinate grid, and this is definitely not going to be drawn to scale, and it's probably not going to be a pretty circle, but I'm going to try my best anyway. So my diameter, remember the diameter is all the way across the circle. I have endpoints at a 4, 3, so maybe about right there, and negative 8, negative 7, so down here. So what I've got is, this is my diameter, so my circle goes through those points. So what I need to do is I need to figure out a couple things. I need to figure out how far it is. I need to figure out what the radius is, okay? I need to figure out where the center of the circle is, and the center of the circle is going to be exactly halfway between the points on the diameter. And we did this in a previous section with finding the midpoint. So the midpoint is going to get me the center of this circle. All right, so to find the midpoint, I need half of the x values, half of the y values. So, or the average of the x values, the average of the y values. Either way, it doesn't matter how you say it. So my x values are 4 and -8. I'm going to add those together and divide by 2 to get halfway between the two. My y values are 3 plus -7 divided by 2. Well, 4 plus -8 would be -4 divided by 2. 3 plus -7 is also -4 divided by 2. So my center, which is my midpoint of the diameter, is located at the point -2, -2, which means h is -2, k is -2. Now, as far as calculating the radius, we can use a distance formula and work it separately. You can calculate the distance from 4,3 to -8, -7, which is diameter. You can calculate that distance and then divide it by 2, because half of the diameter is radius. We can use the center and either one of the endpoints. It doesn't matter. Folks, it really doesn't matter which approach you use, but we do need to find the radius to be able to solve this problem. So if I was to go with the general form of a circle, let's scroll this back up just a little bit. Okay. Let me wipe some mouse real quick. 1 second. No. There we go. So, circle. X minus h squared plus y minus k squared equals r squared. I'm going to go ahead and use the endpoint of 4, 3 because they're both positive numbers. So I'm going to have, plugging those numbers in, my x value that I chose to use is 4 minus h, which is -2 squared, plus my y value is 3 minus my k value is -2 squared equals r squared. And notice again, I'm leaving this in terms of r squared because that's going to be part of my equation in standard form of a circle. So on the first part, I have 4 minus -2. Well, that would be the same thing as 4 plus 2, which is 6. 6 squared is 36. Plus 3 minus -2 would be 3 plus 2. 3 plus 2 is 5. 5 squared is 25. Equals r squared. 36 plus 25 is 61. Equals r squared. And now that I know what r squared is, which would mean, by the way, that the radius is the square root of 61, but r squared is 61, so I can now write my answer. The center of my circle, I've calculated to be at -2, -2. And because they're both negative, I'm going to end up adding h and k. I'm subtracting a negative, which is going to appear to be adding. So x plus 2 squared plus y plus 2 squared equals r squared, which was 61. And that, folks, is the standard form of this given circle. Again, I hope this video has helped. If you have any questions or have any difficulties, please, please, please get a hold of me. That's what I'm here for. Be happy to help you out. Thanks a lot. Y'all have a great day.